Hi, can you guys hear me? Am I audible to you?
Yes, sir.
Okay. I'm really sorry. My internet wasn't working here. So anyway, so we were studying statistics, and in statistics, okay, just wait. Let me share the screen.
Sir,
Yeah,
sir, I have have doubts in four problems in limits and derivatives. Can please help
a
me
bit
with this?
louder, a bit louder. I'm not able to hear you.
Sir, I have doubt in four problems in limits and derivatives. Can you help me with this?
Yeah, of course, of course. Why not? Limits and derivatives, right?
Yes, sir. The miscellaneous actually.
Okay, okay, okay. So shall we go with limits and derivatives first, or statistics? See, last 10 minutes we'll be doing that, okay?
Okay, sir. Yes.
Okay. So hopefully you can see the screen, right?
No, sir.
No? Now?
Yes, sir. Yes, sir.
Okay. Okay, so we were studying statistics. Okay. See, these type. See, yesterday we have seen mean, median, and mode. See, when we have a repeated number of, so here we saw that 13 and 18. So sorry, 3 and 18 are mode. Why is 3 and 18 mode? Because both appear twice, right? Both are the most frequent data point what we are getting. Okay, always try to understand statistics in terms of data point. Okay, that is very, very important. All right, so these type of statistics or these type of mode, what is this called? Anyone, do you have any idea? For this, of course, we are writing for ungrouped data. So in this chapter, actually, we have to study about grouped data. Okay, mostly grouped data will, because in real situation or in real life, we mostly deal with grouped data, not with ungrouped. Grouped data in the sense like a cricket match means a particular player, how much score he's making or she's making, right? Like that. So those all combined score we are taking into consideration, that a team is making this much of score, right? A cricket team is composed of 11 players, and 11 individual players will be scoring some runs, right? That's what we call, or taking wickets, or bowling that much. Okay, so that is a grouped data, not an individual data. Mostly in this chapter we'll be studying about group data. So this type of mode, when you are getting more than one mode, so this we call, can you see? I think, okay, again I'll rejoin. Okay, I think this app is hanging, so just give me a moment. I'll rejoin this, or let me restart. Yeah, it's working. All right, so these type of modes are called by mode. Okay, that means we are getting more than one mode, okay, of this data point, or multi-mode also we call it, multi-mode. All right, and median, we know how to calculate median if we have even number of data points or if we have odd number of data points. And we also know how to calculate this mean is like arithmetic mean we are getting. That means we'll be adding all the data and dividing it by number of data points. That's how we calculate mean. Now in this chapter, mostly we are going to study about grouped data. Okay, so let me write down here, grouped data. Grouped data. Okay, see in statistics we always try to find the central tendency, right? That's what we call. Now central tendency can be of different types, like mean, median, or mode. Central tendency, that means, like I gave you example yesterday, if suppose in our garden there are like a plant, which is one plant is 1 feet, another plant is like, let's say 2.5 feet or 3 feet. Some plants are taller, some are smaller, some plants are of same size, right? And some plants are really tall. So if I ask you one particular question, that was the means what type of plant you have, means in terms of height, of course, you are having in your garden, so you won't be explaining it all about all the data, right? All the plants. Mostly you'll be choosing one central tendency and you'll try to explain using that. Like if you have more number of rose plants, so maybe you will say that, okay, I have um, means like a rose garden or something like that. Or in terms of height, if you want to say, so if most number of, like let's say 3 feet, most of your plant in your garden are 3 feet, so you'll be saying, okay, my garden is like almost 3 feet tall. Okay, or maybe you'll try to find the average of all. Okay, and you'll average it and you'll say, okay, my garden is like 3.5 feet tall. Okay, so we always try to find the central tendency. Or maybe like your in your gardens, like let's say 4 plants are, means most number of plants, means most frequently the plants are of height 4 feet, so you'll be saying, okay, in my garden it is of 4 feet garden, like that. So any central tendency whichever you find suitable, in that situation you will be saying that. So that's what we always try to find in statistics. Okay, that's how we can, from a large number of data, from a very large number of data, we can find pattern. Okay, so we can find pattern, and in that data only we are learning new things. We are training our machines, like we have developed language for machines, like machine learning and all, right? Data science is there, another course. Okay, means we analyze data all the time, data analysis, or yeah, exactly, that part. So all are based on statistics. Okay, in all we try to find the central tendency. Okay, so let's study about that, and what how we can do that. Okay, central tendency, how we can find the central tendency. Okay, that's really important. That's what we have been working out for. Okay, so first, see, to find central tendency, there can be deviations. There can always be deviations. Or see, there now when we are talking about grouped data, that means the data, there are a lot of data points and that are not arranged, or that we can say is scattered. Okay, so scattered data. Scattered data. Scatter about now in scattered data, the central tendency can be found using certain methods. So one of them is mean deviation. See, there are others. See, the major one I'll be writing here, and we'll talk about others later in some separate class, maybe tomorrow. Standard deviation. Now, from deviation, we already know what we mean. What is the deviation from the mean point, whatever you like? If you are finding the mean, that means you are writing x bar, right? That's what we have. And how we explained it, that is 1 upon that is divided by number of data points, and that and we are adding all the data, right? Xi from I is equal to 1 to n number. So that is how we find mean. Now, what is the deviation from mean? So that means deviation from mean can be found using subtracting the value, whatever value we want to find. So let's say the point xi, how much xi is different. Like suppose if I explain you in terms of number line, okay, let's say 4 3 2 1 0. Okay, we have like 5 data points here. Okay, and in this we are saying that if you add, okay, so 2 1 3 and 3 6, and let's say means these are the points. Okay, these are the points. And okay, so let's get one more 5, or let's leave it, let's remove 0 from here to make it easier. That's it. So what's the sum here? 15, right? Now 15, if you divide 15 by how many data points we have? 1 2 3 4 5 5. So that means this is equal to 3. So 3 is the mean here. Okay, so let's say 3 is x bar is equal to 3. Now xi, what is xi? Let's say if I want, if I'm asking you what's the difference between xi, means the mean, and the point 1. Okay, so how you will be calculating now? This is xi, these all are xi point, right? That means this is x1, this is x2, this is x3, this is x4, this is x5, and it turns out to be the mean is x3, right? So here what we are doing, if we are finding the deviation, so deviation means deviation of, let's say, x1. So what's the deviation of x1? So that from the mean point. So how do you find the deviation? So that is x bar minus x1. That's how we'll write the deviation, right? So that this represent the deviation of this point x1 or the point 1 from the mean. This is the mean that we have got. All right. So I hopefully the meaning of deviation is very much clear to you. And of course, if you are good in English language, that means you don't need this much of explanation. But yeah, of course, why not? So mean deviation. First, we are going to study how to calculate mean deviation. Okay. So mean deviation is simply, first we'll be doing it in steps. Okay. So let's write down how to calculate mean deviation for ungrouped data. Right. We are studying for group. Okay. Group, not ungrouped data. I'm sorry. I'm really sorry. It is, we are calculating for ungrouped data. Okay. So mean deviation. Mean deviation for ungrouped data. Ungrouped data. See, I'm not going to teach anything new, but of course it's already there in your book. Okay, so suppose we have n number of data points, like in the previous example I've given you. So this is x1, x2, and so on, and we have till xn. We have n number of data points. So first step 1 will be, so first step 1 is what? We'll calculate the central tendency. Okay, that means what is the central value here? Okay, that means either it can be mean, median, or mode. It can be anything, right? The central tendency can be anything. Let's say now we have to calculate the mean deviation, the deviation from the mean. So we'll find the mean. Okay, what is the mean here? So first we'll be finding the mean. So let's say the central data is some point A, some xi, which we don't know here, which is some xi, which is equal to A, xi, which is A, right? These are xi points. So whatever points these are xi, right? So x1, x2, x3, x4, similarly, so on, right? So suppose that is I. Now we have to find the deviation of each point from A. Okay, so how do we do that? So that means deviation of first point. So x1. So this is the deviation of first point, x1 minus A, right? Now deviation of second point. So x2 minus A. See, we can do the other way around also. We'll get the same result. Don't worry about it. Okay, that means we can write A minus x1 also. Okay. Just the sign will be, some negative or positive. So don't worry about that. Now for the similarly, we'll find for some all data, right? So for last data point, that will be xn minus A. A is your central data. It depends now what data you are taking. Maybe this central data can be mean, this central data can be median, or it can be mode. Okay, it can be mean, it can be median, it can be mode. Okay, so it depends what central data you want. Okay. So these are the deviations, deviations from central point. So let me write deviation of, see, these are xi. Okay, so these points are called xi. So let's write deviation of xi from A, the central data. Okay, A is the central data. Always remember, A is the central data. All right. Now see, since xi can be smaller than xa, means A, x2 means xi, it can be greater than A, xi can be smaller than a, right? Both are possibility. Let's say if some central data, like in this example, if you try to calculate 1 minus 3, so of course you'll be getting a negative value, -2. Now if you calculate a data like 4 minus 3, so you'll be getting +1. That means it is positive, right? Positive or negative. That means now this is your x, sorry, this is your a, this 3 is your a, the central data, which in this case is mean, and this 1 is your xi, this 4 is also xi, right? So xi can be anything. It can be smaller than or greater than. So it's always better to write in absolute value terms. That means we'll just simply put a modulus sign. Okay, absolute value. That means we only take the magnitude. We'll consider only magnitude. Only magnitude. Okay. Hopefully so far it is clear to you guys, right? So if you put magnitude, that means we'll be writing x1 minus a, x2 minus a, or xn minus a. Whatever we get, we always get the positive value, right? Now we have to find the mean of these data. So what are the data points we have now? So these are the new set of data points. Okay, so this x2 minus a. Similarly, all, so let's write in the middle xi minus a, and the last value, let's write xn minus a. So now this is the new deviation. This is the new set of data that you can say the deviation, the deviated data, right? So now if you find the mean of this deviation, the term we use it is called mean deviation. Okay, so let's write mean. Now we are finding just the mean of this data. How do we find mean of this data? So mean of this data will be, we'll sum it up, right? So xi minus a, that's what we have, and we'll be summing it from I is equal to 1, because it starts from 1, right, and ends at n. So 1 to n, we'll sum it up. And how many data points we have got? So we have got n number of data points, right? And see, we are finding what? We are finding mean. That's why we are calling it mean deviation about point A. We are finding mean deviation. Let's write it down. Mean deviation about A, right? About this point A we are finding. Okay, now A can be any central data, right? Now suppose if this central data we are considering mean. Now let's say that A, whatever we are finding is mean. Like if you take example, this is the example, we have calculated a mean, right? So mean, now if A, okay, I'm sorry. Okay, if A is mean, if we are finding mean, that means A is equal to x bar, right? So how do we write this? Now this is written as, so we are finding mean deviation about point A. So we write like that. So now in this case, we'll be writing mean deviation about point mean of the data, about the mean deviation about the mean. So this is equal to 1 upon n summation of I is equal to 1 to n. This we are summing it from 1 to n, and xi. Now instead of a, we'll be just substituting x bar. That is the mean of the data. X bar is just simply mean of the data, right? So let me write it down. So x bar, this is mean of the data. Okay, so we have substituted this, right? A is equal to x bar. Now suppose, let's say if A is the median, if A is the central tendency that we are finding is median, right? So we represent median by capital M. Okay, in statistics, we will be representing it by capital M. So we'll write, now the mean deviation about the median is 1 upon n. Simply we'll substitute instead of X bar, we'll substitute M. That's it. So I is from 1 to N, okay, where M is your median. Yes, so M is your median. All right. Hopefully it's not very tough, right, to find out.
Yes, sir.
Yeah. So let's start solving some of the problems, and hopefully you'll get to it. So let's, of course, why not start with the easiest problem? So find the mean deviation about the mean for the following data. So you have to find the mean deviation about mean, right? Read the question properly. So mean deviation. Okay, let me change the question a little bit. Mean deviation about the mean. Okay, about the mean. Okay, that is very, very important. And the data points that is given to you is 6, 7, 10, 12, 13, 4, 8, 12. Okay, find it out. So first what you'll do, you'll find the mean of this data. First, find out X bar. Find out X bar. Tell me how much is that. So how do you find X bar? It's just the arithmetic mean. Find it out. So how much is the mean you have got? You just add all
9,
the
sir.
data.
X bar is 9.
So 72 upon 8, that is 9. Okay. Now how do we find mean deviation about mean? So first we will be finding, we'll be writing the observation data, right? From the deviation. So deviation data, first write down the deviation data. So this was step 1. Step 2 is write the deviated data. So how you will write? That is 6 minus 9, 7 minus 9, and put a modulus to it. Comma 10 minus 9, and so on. Let me write it down. So 12 minus 9, 13 minus 9, 4 minus 9, 8 minus 9, and again 12 minus 9. Okay, how much is this? So whatever its negative value, we'll just write the positive value. So 3, here we'll get 2, 1, 3, 4, 5, 1, 3. Right? Is it correct? Yeah. Okay. Now this is the set of data that we have got. Now you just find the mean of this data. Okay. So this is the data we have got. Now you find the mean of this data. All right. So this is what this we have got is xi minus x bar. We have got this and the modulus of this, right? We have got this part. All right. So we have got this part we have already got. What is this? Okay. This part we have already got. All right. Now we just need to find the mean of this. So sum it up and divide it by number of terms. So, so mean deviation about mean will be equal to sum up this data. So 3 plus, let me write the using formula. The formula is 1 upon n. Summation from I is equal to 1 to n, and xi minus x bar, right? That's what we need to find out. And in this case, we know the value of n. N is 8, so 1 upon 8. So we have to sum it. I is equal to 1 to 8. Xi minus x bar. Okay, so this value we have already calculated. So 1 upon 8. And this is 3 plus 2 plus 1 plus 3. So let me write down. So 3 plus 2 plus 1 plus 3 plus 4 plus 5 plus 1 plus 3. How much we have got? Anyone please tell me? So this is 3, 2, 5, 6, 7, 8, 9, 10, 13, 13, 5, 18, 19, 20, 22. So 22 upon 8. How much is that? So that is 16. That means 2 point. Okay, so how much we have got? 6, 8. So that means 7. Now we divide it. Okay, so 5. So 2.75. So mean deviation about the point, about the mean is 2.75. Okay, so that is our answer. This is the mean deviation about mean. Now in the same data, if I ask you to find mean deviation about median, how you will calculate? So first you'll find out the median. Which one is the median here? So first you will arrange it in the ascending or descending order. Okay, so arrange it 4, 6, 7, 10, 12, 12, 4, 6, 7, 8, 10, 12, 12, 13. So write down 4, 6, 7, 8, 10, 12, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8. Now, since we have 8 points here, okay, 8 points. So the median will be, there will be 2 medians. Okay. Now, if you have 2 medians, so this is, let's say M1, and let's say this is M2. So first, as of now, we don't know how to group it. So first what we'll do, first we will find out mean deviation about M1, and then we'll find out mean deviation about M2. Okay, so before that, we need to find out xi minus M1 modulus, of course, and xi minus M2. Okay, that means we'll be getting 2 mean deviations about median. Okay, understood? And about mode, so what is the mode here? Anyone? What is the mode of this data? See, which is the most frequently appearing data?
Sir, 12.
12. So 12 is the mode, right? So if you are asked to find the mean deviation about the mode, how you will find out? So mean deviation about mode, how you'll find out? So that means 1 upon, you'll find the mean of that data. I is equal to 1 to n, and xi minus the mode. Mode is 12 in this case. Understood? Understood or not?
Yes, sir.
You just see here in this case, we found using median, sorry, mean deviation about mean. In this case, the second case, we are finding mean deviation about the median. Mean deviation about the median. And in third case, we are finding mean deviation about mode. Okay, so it's just you have to substitute it here. That's it. That's it. That's what the meaning is. Okay, so first, okay, okay, so try to solve question number. Okay, ungrouped data we haven't done, right? So this is the grouped data that we have talked about. Group data or ungrouped data? What we have talked about here? This is ungrouped data, no? This we have talked about ungrouped data, sorry. So let's talk about group data. So mean deviation about group data. Mean deviation about grouped data. So grouped data, all right. So see, in group data, we can have either frequently distributed data or continuously distributed data. What do we mean by frequently distributed data? Anyone? Anyone? See, discrete frequency distribution means, that means suppose you have a bag, and just imagine like you have coins. Okay, so you have 1 rupee coin, 5 rupee coin, 10 rupee coin, and 20 rupee coin. Okay, and 2 rupee coin also. Okay, so 1, 2, let's say 1, 2, 5, 10, and 20 rupee coin. And you have like some 20 rupees coin. Okay, some 5 rupees coin, some 2 rupees coin, and some means all the coins are having certain numbers of coins. Okay, or all the this 1, 2, 5, 10, or 20. These all coins are present in different numbers. That means they are present in particular frequency, right? So those type of data is called discrete frequency data. Okay, these type of data are called discrete frequency data. That means we don't know. Like, let's say there are means 100 of 1 rupee coin, 1 rupee, 1 rupee coin. There are, let's say, 10, 20 rupee coin. Okay, there, let's say there are 15 or 18 10 rupee coin. Okay, there are 5 of 5 rupee coin, and there are like 200 of 2 rupee coin. Got it? So these are discrete frequency, right? It's not like they are all present in same amount. So these type of data are called discrete frequency data. Understood? Now, what is continuous frequency data? That means they will be present in like 200 rupees coin. Like all are present in 100. All the numbers are same. Okay, all the data have same numbers. Like this 100 rupee coin is also present. 10. There are 10 100. Sorry, there are 10 1 rupee coin. There are 10 2 rupee coin. There are 10 5 rupee coin. There are 10 20 rupee coin, and so on, whatever it is. So that type of data is called continuous frequency data. That means if you can solve problems based on discrete frequency data, it's always easy to convert it to continuous frequency data. Okay, so let's say you have a data point, let's say X, and it is present in F, that frequency, F number of times. Okay, and let's say it is X1, let's say 1 rupee coin, that's the example that I gave you. And there are n types of coin you have there, and they are present F1, F2, and Fn number of, means whatever coin is, let's say this is 20 rupee coin, so it is present like 100 of them are there, or in this case it is 10 of them are there, whatever, we don't know. So all the coins are present in different number of data. Okay, so that type of data is called discrete frequency data. All right, so how do we find the mean deviation about mean of these type of data? Mean deviation about the mean. Mean deviation about mean, how do we calculate it? So first we will find the mean of the data. Okay, obviously we have to find. So first we will okay, let's go it in an easier way. So first we will multiply these two data, like whatever. See, 10 of 1 rupee coin, that means that is 100 rupees. Sorry, 100 of 1 rupee coin. Like 200 of 2 rupees coin, so that is 400 rupees. So we are all finding in terms of rupees, a common data. So first we'll multiply these two. Okay, that means, so it is Xi and this is Fi. So first we'll find out Xi into Fi. Okay, that will be our step 1. So step one, find Xi into Fi. That is step 1. So step 2, what we'll do now, we will sum it up. So find the summation of Xi into Fi. So I is from 1 to n. There are n number of data points. Okay, now what we'll do, find the sum. Step 3, find the sum of the frequencies Fi. Okay, so I is from 1 to n. All right, now the last step that we do, step 4, is divide step 2 by step 3. That means we are finding the mean, right? So that means we have to divide with the data points. Xi Fi divided by summation of I is equal to 1 to n into of the frequency. And this is the mean. That's how we are finding the mean, right? So this is the mean of the data. So first we have got mean. So this will be equal to, let's write down. If you write this is equal to capital, or let's just leave it. See, it's like we don't want to write it all the time. So let's say if it is n, so let's write it in that term. So 1 upon n, summation of I is equal to 1 to n xi into fi. Okay, so that's what we have got. So this is now we have to find the mean deviation about the mean. So step 5, of course we have the similar manner we have to find out. So what we'll find out, so this one, see, we have found xi into fi, right? Now we have to find the deviation. So deviation will be what? So again, we'll make one more column, one more row actually. So this, let's say deviation data. So it is x, let's say we are finding with respect to mean. So xi minus x bar, right? That is the mean, or let me write it down properly. So suppose the mean of this data, whatever we have got is x bar is the mean of the given data we have found out. So that will be x1 minus x bar modulus. Now similarly, in the case that we have done previously, x2 minus x bar, and so on till xn minus x bar. Okay, now what we do, this is the deviation from the mean position. Okay, now we'll take the product of frequency and this. So deviation into f, frequency. So how many times that is present, right? So that you will be writing x1 minus x bar into f1. So f2 into x2 minus x bar, the mean. Similarly, the last will be fn xn minus the mean. Okay, this data. Okay, so what we can write it here, this we can write is, so we have got, now if you add it all, we'll find the summation I is equal to 1 to n of the data fi into that we have got, the fourth row. Okay, we'll add all. So this is xi minus x bar, the mean, about, because x bar is the mean here. Please remember, x bar is the mean, xi is the data, fi is the frequency of that data, how many times that data is present there. All right, now we'll take the average of this, right? That's what we are taking. We are calculating the mean. So take step 6, take the mean, take the mean. So that is called mean deviation, mean of the deviation. So this is the deviated data. Okay, so find the mean of that data. So this will be about the mean. We are finding the mean deviation. This will be writing. So I is equal to 1 to n fi into the product, the difference. So I about the point mean, whole divided by the frequency, the sum of the frequencies. I is equal to 1 to n, right? And this we are calling capital N. So we can write 1 upon n. Okay, and this data I is equal to 1 to n fi into xi minus x bar. Okay, so that's how we find mean deviation of a group data in your discrete frequency distribution. Okay, so this is the mean deviation of grouped data of what type of discrete frequency distribution. So grouped discrete data. Let me write here, grouped discrete data. Understood? So we just need to follow this step. First, we will find the mean. First, we will find the mean of the data point, data whatever given, distribute this discrete frequency distribution. We'll find the mean of that. Then only then if you take the mean deviation, then we'll calculate the deviation. Then we will take the mean. We'll find the mean of that deviation. Okay, about mean. We are finding about mean. Always remember, we are finding about mean. X bar represent mean. Okay, so that's how we are going to calculate. We'll solve problem based on this tomorrow. And yeah, of course, Murli, you had some doubt. Please tell me what doubt I can clarify.
Sir, yes. Limits and derivatives miscellaneous exercise.
What?
Limits and derivatives miscellaneous exercise.
Yeah, tell me the problem. You tell me.
So cos of x minus pi by h. Have to find the derivative.
H minus
X minus pi by h.
Okay, x minus pi by
8.
Yeah.
I have to find the derivative from using the first principle.
Okay, using the first principle we have studied, right? So you have to
Yes,
about which point you have to find.
Sorry, sir.
Okay, derivative you have to find about which point.
So they said using the first principle. So for this sum, I'm not quite sure how.
Using first principle.
Yes.
See, first principle, how do you find derivative? Do you remember?
Yes, sir. We do limit h tends to 0, and then we add here. 1 second.
Yes, tell me. You are correct.
Yes, sir. Yes, sir. So
when do we say derivative? When do we say the derivative exists or do not exist?
The derivative won't exist if
see, left hand derivative should be equal to right hand derivative, right? Yes, so how do we find left hand derivative? Right? A minus, isn't it?
Yes.
How do we calculate it? F of? Yeah, go on.
I'm not quite sure for this sum.
H is equal to 0, f of x plus h minus f of x upon h.
Yes.
This is about 0. That is very familiar to you, right? See, this is. Can you hear me or not? Tell me that.
Yes, sir. Yes, sir.
Right? You can hear me?
Yes, sir.
Because you are not audible to me properly.
So I have some internet issues. I can
What?
So I have some internet issues, but I can hear you.
Okay. So see, you know about this point 0, but in this problem you have to tell me about which point you want to find the derivative using the first principle method, because you need a point to find a derivative. Simply you cannot say that you want to find. I suppose it is about pi by 8. I think. That means you have problem in first principle method, right?
Yes.
First principle method. Okay. What else?
So this sum and this another sum is I have to find the derivative of sine to the power nx.
Sine to the power of nx.
Yes, sir.
Okay, so we have done this, no, in class? No.
Not sure.
See, I'll tell you. Okay, this is compound derivative. Okay, so let's say y is equal to this. So if y is equal to this function, so how do we find the derivative? So dy upon, let's say we are finding with respect to x, because it's not given, or you are not saying with respect to what we are finding. So let's say we are finding with respect to x. So this will be equal to, you just simply write d upon dx of sine nx, right? Now you treat, I'm not going to tell you the answer. You solve it today and you tell me tomorrow, okay? Use this principle. So we know the derivative of x to the power of n, right? So that is dy upon dx is equal to nx to the power of n minus 1, right? Isn't it?
Yes. Yes.
And dx upon dx, which is of course 1, that's why we don't write it. Okay, but always write in this manner. Okay, like if you are finding dy upon dt, okay, so what you will write? Nx to the power of n minus 1 dx upon dt. That's how we write it. Okay,
Yes.
so that you can cancel out dt here, and just dx will come here. So it will ultimately become the same thing. Okay, so but this is the correct method to write it down. All right, I think I have explained that one. So use this principle, number 1. Okay, now, okay, then again use this. Yeah, use this one. From this one only you will get it. Now instead of x, you have sine x. Okay.
Yes.
Instead of x, you just substitute sine x, and you will get the answer. Okay. But
So, yes, sir. So I'll get n sine to the power n minus 1 itself. But the
no. See. Okay. See, dy upon dx we are using here. I said now x, this is sine to the power of nx, right?
yes, sir.
So,
Yes, sir.
so you will write n x instead of x, sine to the power of n minus 1x. Okay.
Correct, sir.
Now
And cos
d
x.
into sine x upon dx. You are forgetting here. Here you also have x, right?
Yes, sir. Same doubts. So I have to write n sine to the power n minus x, n minus 1 x
Yeah,
into cos x.
yeah, that the because the derivative of this is what? The derivative of sine
Cos
x
x.
is what? Cos x, right? Okay. See,
Yes.
first principle method, it takes a little time. So let's do it tomorrow. You already have chemistry
Okay.
class, I suppose, right?
Uh,
Okay.
so
Okay. So 2 more doubts. No, first what we'll do, we'll clarify your doubts tomorrow. Okay. Then we will
okay.
start. Okay.
Okay.
So one is this one. Tell me other 2, so that I'll be
Sir,
prepared. Yeah.
okay. So x power 4,
X to the power of 4,
bracket open, 5 sin x
5 sine x
minus 3 cos x.
minus 3. So what's there?
Sir, the thing is, I'm not sure in what order I'm supposed to solve. So first, the x power.
Any or whatever order. See, either you can multiply it, or you can just use the product rule. It's all correct. Every time you'll get the same answer. Tell me what else.
Okay.
Try it again. Okay. This is
Okay.
very easy. Tell me what
Okay.
next.
X square cos pi by 4.
X square
Cos pi by 4.
pi by 4.
Y sin x.
This by sine x.
Yes, sir.
See, cos pi by 4 value. This is a constant. No, cos pi by 4 is just a constant,
Correct.
isn't it?
So, yes, sir.
So you can either, what you can do, either you can write cos pi by 4. Let's say this is y. So cos pi by 4 into x square into cosecant of x, and you can use the product rule here, right? It's a
Yes,
constant.
sir.
So pi upon dx will be just cos pi by 4. Cos pi, just substitute the value, it's fine. D upon dx of product rule, you can just use the product rule here.
Yes, sir. Sir, when I see these kind of questions, I would also. So, I'm supposed to use the quotient rule, or I'm supposed to do the
Any
direct
rule.
process?
See, any rule, whichever. See, here cosecant takes direct derivative. If you remember, use this. If you don't remember cosecant derivative, use the quotient rule. So you can also write, what is cos pi by 4? 1 upon root 2. Is it?
Yes.
Is it?
Sir, sir. Yes, sir. One by root. Correct.
1 by root 2. Okay. Now you can use this also, d upon dx of x square upon sine x. If you want both, you will get same answer.
Okay, sir.
Okay. So try it one more time. Okay. And okay, I'll help you out with you with this first principle tomorrow.
Yes, sir.
And again, I'll explain the product rule and this rule again. I'll explain it tomorrow. Okay. Okay. Thank you so much. I'm really sorry I've taken a lot of your time, but I suppose chemistry syllabus is finished, right?
Yes,
Yes,
sir.
sir.
Oh, okay. So probably you will be revising only. So okay. Okay. Thank you so much. Bye.
Thank you, sir.
Thank you, sir.